Hello everyone, it's me, Sanjay Vasu, back again for another video. This time doing it on Cambridge O-Level Mathematics, Syllabus D, Paper 2, which is the calculator paper. This is a specimen for examination from 2025. And this time, I'm going to be doing part 2 of a two-part series on this paper, which is questions 14 to question 25. Let's start. Before we go to the questions, I'll note that there is a list of formulas which is given at the start of all O-level papers, and these formulas are always there in those papers. Therefore, if you forget a formula, if it's in this list, you can always refer to the formula sheet to remember it. The table shows the distances traveled by 80 people to a shopping mall. Calculate an estimate of the mean distance traveled. First, we can find the midpoints of these classes. So 0 less than 3 less than equal to 5. Midpoint is 2.5. We just add the two class width values or the endpoint values, divide by 2 after we added it. And we get these values. We get 7.5, 15, and 35. Now, an estimate of the mean, that's going to be equal to the sum using this symbol, which is called sigma. We can represent the sum. And that's the sum of the frequency times the midpoint, which I'll just label as x, and divide by the sum of all the frequencies. And notice that we cannot cancel these out to get frequency only because this is written together. Some people even write a bracket here to not confuse between it. So we can write this as 2.5 times 35 plus 7.5 times 20 plus 15 times 14 plus 35 times 11. And this whole thing dividing by the total frequency, that's the number of people, 80. And let's just plug this all into the calculator at once. Let's see, 2.5 times 35 plus 7.5 times 20 plus 15 times 14 plus 35 times 11. We get 832.5 dividing by 80. We get 10.4 kilometers, and we can write this to be significant. You can write down the full value if you want. I was just writing 10.4. That's our answer. Let's go over to question 15. The diagram shows triangle A and B. Describe fully the single transformation that maps triangle A onto triangle B. We can see that this is a rotation, since it does not look like it's been reflected in any way. Its orientation has been rotated 90 degrees. So there's a rotation, and as I just said, it's 90 degrees. And which direction? That's obviously going to be this way, or in terms of a name, it's clockwise. And what is the center of rotation? We can find that by visualizing a bit. So we take a few points on the grid and try to see if it's the center of rotation or not. And over here we can try some points around here, since if you rotate around this point, it's going to be going below. If you rotate around somewhere on this side, it's going to be going this way. Therefore, we have to try it around this general region. And trying this point, if we get there, 2, 1, we'll see that when we rotate, we have 3 units going 90 degrees clockwise, once again 3 units to a corresponding point on B. Now if we use this point, it's 5 units, and if we rotate this way, we still get 5 units. And as for this point, compared to this, it's 5 down, 1 left. Rotating 90 degrees, get 5 left, 1 up. The dimensions are the same, even though the direction has changed due to the rotation. The dimensions are the same, therefore, center is 2, 1. Why? It's because the lengths from the rotational point or the center of rotation are the same for all corresponding points. That's the answer. Now going to question 16. Question 16. Sketch the graph of each function. A, y equals x minus 3. So in this case, the gradient is going to be 1, and the y-intercept, c, is going to be minus 3. So the y-intercept is going to be below the x-axis, and the gradient's 1, so we just draw it approximately like this. It has to be a straight line, of course, since there's only one power of x in the equation. Also, we can label this point to be 0, comma minus 3, and this point also can be labeled as 3, comma 0. Since with a gradient of 1, we increase 3, because the change in y by change in x has to be 1. Therefore, we get to 3, comma 0 from 0, comma minus 3, which is the y-intercept. B, y equals 1 by x. Now this one is a simple reciprocal graph. X and y axes are asymptotes, and therefore the lines will approach them, or the curves will approach them, but never touch them, even when we move x and y to infinity, or negative infinity. This is the correct answer. Now going to question 17. An insect population decreases at a rate of 12% per year. The insect population on 1st January 2022 is 3.7 million. Calculate the number of complete years it'll take for the insect population to first fall below 1 million insects. So decreasing at a rate of 12%. That means 3.7 million, 3.7 times 10 to the power 6, multiplied by 1 minus 12%, that's decrease, so 12% is 12 by 100, to the power of n. N is the number of complete years, and that has to be less than 1 million, which is 1 times 10 to the power of 6. You can cancel 10 to the power 6 from both sides. Now 1 minus 12 by 100 is 0.88. This to the power of n is less than 1 by 3.7, or that's 10 by 37. And now we can take the log to the base 0.88 of both sides. And doing this whole thing will be cancelled to get the n value here. And if you don't know why, there is a log formula saying that log base a of a to the power of b is simply equal to b. In this case, a and b are two real numbers. So in this case, 0.88 is the same over here. That's why we've used to cancel out all of this and to get n. And n is less than. Now, because we're doing a log, we have to flip the sign. And if you got the answer correctly using a calculator, you can get 10.23 years. And therefore, n equals 11 years for the smallest possible whole number value. Let me just write that directly there. There's no space to write here, that's why. Alright, we need the number of complete years, that's why I'm writing a whole number value, which is greater than 10.23. It must be 11. You can't write 12 because before 12 years, it's 11 years, and already it's less than 1 million. 12 is only after 11, so it's not to first fall below. Question 18. Y is inversely proportional to the cube root of x. Given that y equals 2.5 when x equals 8, find y when x equals 64. So if y is inversely proportional to the cube root of x, that means y is equal to, inversely proportional is this, y equals k by the cube root of x. And therefore, we can substitute the two values which are given, y equals 2.5, x equals 8. That'll be k by 2. So k is equal to 2.5 times 2, which is 5. Now, y is equal to 5 by cube root x. And in this case, substituting x equals 64, we get 5 by 4, which is 1.25. That's the answer. Now going to question 19. ABCD is a quadrilateral with AB equals 500 meters, BC equals 650, DA equals 350 meters, all given here. These two angles are also given, angle DAB and BDC. A, calculate DB. We can calculate this using the cosine rule. So A squared equals B squared plus C squared minus 2BC cos A. And if you forgot what the cosine rule is, of course you can just refer to the front page of the paper, where I told you at the start of the video that there is a formula sheet, and you can always see this formula there. So A squared is equal to B squared 500 squared plus C squared 350 squared. You can use B as 350 and C as 500. It doesn't really matter. The answer won't change. So 2 times 500 times 350 times the cosine of the angle between the two sides, 135. and therefore A is equal to the square root of this number, 250,000, and then plus 122500, and then minus this value here, which we can put on our calculator. So 2 times 500 times 350 times the angle, which is 135 cosine, to get minus 247, 487. This is to separate the thousands, and then 0.373, so on. And now let's do this. So we can do 250,000 plus 1,225,000, and the minuses will cancel, so we can bring it to positive, and then plus these two values, and we get plus 250,000 to get, when you square root, 787.39 meters. That's the answer. Now going to part B, calculate the obtuse angle BCD. So first let's calculate normal angle over here. We can use the sine rule since we just found BD. So A by sine A equals B by sine B. And in this case, we can write A as BD, which is 187.39 divided by the sine of angle BCD, which is what we want. Angle BCD is equal to B, which is 650, by sine 52, the opposite angle, which is this angle over here, this side. Now we can find angle BCD, the sine of it, and that will be 77.39 times sine 52 divided by 650 if we flip this fraction and bring this to the other side. So we can multiply by sine 52 divided by 650 to get this value as the sine, 0.954, and therefore angle BCD is equal to the sine inverse of this, which is 72.66 degrees. Or we can write this to one decimal place as 72.7 degrees. Now the obtuse angle BCD, which is what we need to find, it has to be between 90 and 180 degrees. It cannot be equal to 90 and it cannot be equal to 180, but it has to be between the two. So we can do 180 minus 72.7 to get the obtuse value, which could be this value, right? And the 180 minus 72.7 is going to be 107.3 degrees. That's our answer. Now we can go to question 20. Shanti travels 12 kilometers from home to school. She travels an average speed of x kilometers per hour. A. Write down an expression in terms of x for time taken in minutes for Shanti to travel from home to school. So the time is going to be distance by speed, which is equal to 12 by x. But notice that this is in hours. So you multiply by 60 to get the time in minutes, which is going to be 720 by x. Now part B, Felix travels 12 kilometers from home to school. He travels at an average speed 20 kilometers slower than Shanti's average speed. Notice that there's going to be x minus 20, since 20 kilometers slower means 20 kilometers less. Kilometers per hour. And write down an expression in terms of x for time taken in minutes for Felix to travel from home to school. And that will be distance by speed again, which is 12 by x minus 20, but this is in hours once again, so you multiply by 60 to get 720 by x minus 20. Now part C, Felix takes 15 minutes longer to travel from home to school than Shanti. Use your answers from part A and B to form an equation in x, and so it simplifies to x squared minus 20x minus 960 equals 0. So we can write 720 by x, which is the time for Shanti, is equal to the time taken for Felix, which is 720 by x minus 20, minus 15 minutes. Now we can bring the fraction completely together. Minus 15 times x minus 20 by x minus 20. And now you can write 720 times x minus 20 is equal to 720 minus 15 times minus 20. That'll be minus 15 times minus 20, cancelling the minuses. 15 times 20 is 300. So we can write 1020 minus 15x whole thing times x, because we're bringing the x from the fraction up here. And therefore, 720x minus this value, 720 times 20, which is going to be 144 followed by 2 zeros, and that'll be equal to 1020x minus 15x squared. That means 15x squared minus 300x minus 14400 equals 0, bringing these two to the other side. And dividing the whole thing by 15, we'll cancel this, we get 20, and we get 960. Therefore, we can prove that x squared minus 20 minus 960, 20x, minus 960 is equal to 0. That's the answer. Why is that the answer? Because it's just shown that it has to simplify to this. Let's move on to part D. Solve the equation x squared minus 20x minus 960 equals 0. Show your working and give your answers to 2 decimal places. Since there's 2 decimal places, we know that we have to use the quadratic formula, since this is probably not going to be able to be factorized. So this can be written as x equals minus b plus or minus root of b squared minus 4ac by 2a, the quadratic formula. And we just substitute the values of a, which is 1 here, b, which is minus 20, and c, which is minus 960. So 20 plus or minus root of minus 20 the whole squared minus 4 times 1 times minus 960 divided by 2a. And here a is going to be 1, so we just 2 times 1. That'll be 20 plus or minus, let's get our calculator out. Here we go. Now 20 squared is 400 plus 4 times 960, because the minuses will cancel out over here. And now we do a square root of this value to get 65.115, and then divide by 2. So if it's 20 plus 65.115, then we'll get the value of 42.56 to 2 decimal places, of course. Or now if we take minus of 65.115, so 20 minus 65.115 is equal to this, divide by 2 to get minus 22.56. And these are going to be our answers. Now going to part E, calculate the time Felix takes to travel from home to school. Give your answer in minutes and seconds. So time taken by Felix is given over here, 720 divided by x minus 20. In this case, x has to be positive, right? Since time can only be positive, so x has to be positive, and in this case, the x value which is positive, 42.56. Now we can do this, 720 by 42.56 minus 20, and let's do that on our calculator. 720 divided by 22.56, that's 42.56 minus 20, so we get 31.91, and this is in minutes. And now we have 31 minutes, of course, since there's a whole number part. And now let's just subtract and multiply by 60 to get the number of seconds. So this is 55 seconds. How do we do that? We just subtracted the whole number part. Only the decimal part is going to be number of seconds, and we multiplied by 60 because seconds is 60 times minutes. So 31 minutes and 55 seconds is our final answer. I rounded it to the nearest whole number for seconds. Now let's go to question 21. Question 21. The table shows some values for y equals x cubed by 3 minus 2x plus 5 correct to one decimal place. A. Complete the table. So minus 3 we can substitute into this. So you get minus 9 plus 6 plus 5, which is 2. Now as for 3, we can get 3 cubed by 3 minus 2 times 3 plus 5, which is simply going to be 9 minus 6 plus 5, and doing that we get 8. Now part B, draw the graph of this equation for minus 3 less than equal to x less than equal to 3. Let's label all the points. Minus 3, 2, minus 2.5, 4.8, minus 2, 6.3, minus 1, 6.7, 0, 5, 1, 3.3, 2, 3.7, 2.5, 5.2, and 3, 8. These are all the points. Now you can draw a smooth, continuous curve between all of them. You have to make sure that it passes through each point correctly. That's the answer. Now going to part C. Drawing a suitable line on the grid, find the roots of the equation x cubed by 3 minus 1.5x plus 1 equals 0. How do you bring this back to our original equation over here? So you can write this as x cubed by 3 minus 2x plus 5, which is the original equation, and then we do something to this to get the equation given. So what something is that? We just add 0.5x and we subtract 4, and that'll be equal to 0. Now x cubed by 3 minus 2x plus 5 is the graph given. Now you can bring the remaining contents to the other side. 4 minus 0.5x. This is the line we're going to draw, since the intersection points between these two will solve this equation. So now we can make a table of values, x, y, and something like this. Now minus 3, minus 1, 1, 3. I'm just making 4 points, but you can add more if you want. And that'll be 5.5, 4.5, 3.5, and 2.5. Now we can mark these points which we found. So minus 3, 5.5, minus 1, 4.5, 1, 3.5, and 3, 2.5. Now we can just draw a line connecting these, and then we can find the intersection points. So firstly, we have minus 2.4. Next we have 0.7. This looks like 0.6 because the pen which I've used here is extremely thick, but then if we draw it using a thin line, it'll actually appear as 0.7. And now for the last one, it's going to be 1.5. Once again, it does look like 1.6, but then if I drew it with a thinner line, it would be 1.5. So these three are the correct answers. If your answer is anywhere very close to these, it is still correct. Minus 2.4, 0.7, 1.5. Let's go to question 22. The length of a pencil is given as 16 centimeters, correct to the nearest centimeter. The length of a pen is correct to the nearest millimeter, but it's 14.7 centimeters. Calculate the upper bound for the difference between the two lengths. So 14.7 centimeters is 147 millimeters. Now the upper bound for the difference is going to be the upper bound of the pencil length minus the lower bound of the pen length. Since the pencil length is greater than the pen length, so we want the highest possible pencil length and the lowest possible pen length to get the upper bound between the difference. So that'll be equal to 16.5 centimeters. Since it's correct to the nearest centimeter, we add 0.5 centimeters, and then we subtract 146.5 millimeters, since this is the lower bound, correct to the nearest millimeter. And that's 16.5 minus 14.65 in centimeters to get 1.85 centimeters. That's the answer. Question 23, expand and simplify these brackets given here. So x minus 2 times 4x plus 1, we can expand this first. 4x squared minus 7x minus 2 whole times x minus 5. Now we expand this. 4x cubed minus 7x squared minus 2x. We multiplied this. Now we multiply this with minus 5. So minus 20x squared plus 35x plus 10. Now we can just write this out. 4x cubed minus 27x squared and then plus 33x plus 10. That's the answer. 4x cubed minus 27x squared plus 33x plus 10. Now going to question 24. ABCDE is a rectangular base pyramid. AC and BD intersect at F. So the two diagonals intersect at F. EF is perpendicular to FC. They form a right angle triangle. AD equals 12 centimeters, DC equals 8 centimeters, and EC equals 16. A, write down the number of planes of symmetry of the pyramid. We can see that since this is a rectangular base pyramid, there's one plane which cuts down the vertical length here, and a much better drawing, it will be like this, which cuts through the middle of AD, the middle of BC. And the other one is going to be somewhat like this, which cuts through the middle of AB and the middle of DC. There's only two, since the diagonals don't count, because it's not a square base pyramid, it's rectangular base. Now part B, show that EF equals 14.3 centimeters to 1 decimal place. Well, we can find AC using AF plus FC equals AC. F is the midpoint of AC since it is the intersection between the two diagonals of a rectangle. So we can find AC, that's equal to square root of 12 squared plus 8 squared, since AD squared plus DC squared equals AC squared. So we do the square root of this squared plus this squared. And doing that, we can use our calculator. 12 squared is 144 plus 8 squared is 64. 208. Now square root is 14.4222 centimeters. I'm not rounding this off because only at the end of the question you're supposed to round off to 1 decimal place. Before that, it's not good. Now, as for FC, we just divide by 2. Alright, FC equals AC by 2. And let's do that real quick. 7.2111 ... Well, now we can find EF. That's equal to the square root of EC squared minus FC squared. Since this squared equals this squared plus this squared, so EF, which is what we need to find, when we square this, we get EC squared minus FC squared. And we square root both sides to get EF. So we get, let's do this on the calculator. First of all, let's just write it down. 16 squared minus 7.211 squared. So let's square this and then negate it, plus 256, which is 16 squared. Right here, 204. Now we do a square root to that, which is 14.3 centimeters to 1 decimal place. And since this is what is given in the question, we can write proven down below. Now for part C, calculate the angle between the line EC and the base ABCD. So since we know EC and we know FC and we know FE, all three sides, so we can use any two sides and we can find this angle. So in this case, I will use EC and FC. So the cosine of the angle ECF, which is the angle between EC and the base, that will simply be the adjacent, which is FC 7.211, and then dividing by the hypotenuse 16, and we get angle ECF is the cosine inverse of these values, and we get, using calculator, 7.2111 divided by 16 to get this, and then we take the cos inverse of this, 63.2 degrees to 1 decimal place. That's the answer. Now going to question 25. The diagram shows a bowl in the shape of a frustum. Calculate the volume of the bowl. First, we need to realize that the frustum is actually a cone with its top part cut off. So if we just extend it to find the edges right here, and we know that this length is, or at least the height is 9 centimeters, that's what's given here. We have this is 6, this is 8. The inner radius is 6, outer radius is 8 centimeters. Now, using similar triangles, we can find out what this total height is. Don't believe me? Well, watch. So, we can draw a line all the way down there. And since this is one line, this angle is the same for both a large triangle and a small triangle. And these two angles are both 90 degrees. So we can show that these two triangles are similar. They have the side lengths which have equal angles, which means 90-90. This angle is the same for both triangles, the outer and inner, and therefore if two angles are the same, the third one is obviously going to be the same. So these two triangles are similar triangles. We can write that, similar triangles, and this is how we're going to prove that we can find this height. And after that, we can find the volume of the bowl. So let's take this missing height over here as x, or the height of the smaller cone as x. Now x is to x plus 9 is equal to, which means the ratio of the small height is to the larger height, x is to x plus 9, is equal to the ratio between the small radius and large radius, which is 6 is to 8. That means you can convert to fractions. X by x plus 9 equals 6 by 8, and that's 3 by 4. Now, we can cross multiply, and 4x equals 3x plus 27. Therefore, x equals 27 centimeters. Now you can find the volume. I'll just erase this since I need some space. I'll draw the x in here. So the volume is going to be equal to, let me just make space, that's equal to the volume of the larger cone, which I'll represent using 1 by 3 pi r squared h with a capital R, or in other words, the volume of this cone, and then minus 1 by 3 times pi r squared h using a small r to denote the volume of the smaller cone. And we can write this is r, this is capital R, and oh yeah, I forgot, this h should be capital H since it is the large cone, and this h is small h since it is the smaller cone. In other words, this h is equal to x, the capital H is x plus 9. Now we can simply replace with all the values we have found. Pi times 8 squared times 27 plus 9, which is 36, and then minus 1 by 3 pi times 6 squared times 27. And doing this on our calculator, the whole thing, we can do 8 squared times 36, and then minus 6 squared times 27, and then we can multiply the whole thing by 1 by 3 pi, since we can factorize this out at the start. So divide by 3, multiply by pi, to get 1394.867 And we can write this as 1395 centimeters cubed to the nearest whole number. And this will be our final answer. We can write it to a better degree of accuracy, like 1394.87 is also fine. Even if you write 1390, it's fine because three significant figures is allowed. Well, this is the answer for the question. And with that, I come to the end of the paper. Please like this video, subscribe to our channel, share this video with your friends and family, and comment on how you think this video was. With that, it's me, Sanjay Vasu, signing out. Thank you. Bye.